Hi everyone, I hope you are doing good. So today in this advanced C++ series, we will take a new C++ topic, and that is variadic functions, right? In last session, we have discussed in detail with the templates, right? We have covered all the aspects and scenarios of the templates, like what is the template, how can we declare, define and use the template, types of the templates, right? Function class and variable templates. We have discussed in detail with examples. Then the parameters of the template we have discussed, right? Template meta programming we have discussed, right? So before watching this video, please watch that video so that the concepts of the templates will be clear to you, right? And then this session would be very easy for you to understand, right? And watch this video till end so that once you know the variadic functions, what is the variadic functions, then it would be easy for you to understand the uh, variadic templates and then fold expressions. So these are the upcoming sessions which we are going to discuss. So in this session, we will discuss the need of the variadic functions, right? What is the variadic functions? Then how can we use the variadic functions, how it works internally, and what are the types, or you can say supported types in the variadic functions, right? And the limitations of the variadic functions. So all these, like basically in these sessions, all the aspects related to the variadic functions we are going to cover. Correct? So let's start why it came into picture, what is the need of the variadic functions. So for example, let's take a simple example here. I hope you know about the function overloading, right? Uh, so here, for example, we have a requirement that we have to write a functions which can take only 2 arguments. Then we can do write this, right? Similar to this one, this is a function print number, non-variadic, non-v, which is taking 2 arguments here. Correct. Now the requirement may come with 3 parameters basically. So we can overload this one and we can add one more definition. If the and then again if the requirement comes like add a functions for four arguments, 5 arguments, right? So similarly, without currently what we can do, we can overload the functions according to requirements, right? And we can add the another definitions. Correct. So this is the simple thing. But now, don't you think it is not a good way? Because is if we have something like which we can which can take the variable number of arguments, right? In that case, what will happen? In that case, no need to add separate definitions, right? So for example, here let me add one more definition here. So for example, here, right? So uh, our requirement is we have to add functions which can take only 1 argument. So now we have 2 definitions. What I did, I just overloaded the function for the 1 argument. This is for the 2 argument. If I need, I can add for the 3 arguments also, 4 arguments also, right? So this was the problem with traditional C++ language, where if for variations in the number of arguments, right, we have to add a new definitions, right? And this feature is already there. Function overloading is already there, right? So using that function overloading, we can basically we used to serve this requirement, right? So now then, and this is very this is not a good, right? Because each and every time we have to add a new definitions for the uh, either in number of increase or decrease in the argument list. Then we have to add a new definition. C++ came with a new feature, that is function variadic or variadic functions. Variadic means variable number of arguments, a function which can take variable number of arguments, right? So let's understand the variadic functions. So I hope it is clear to you what is the requirement and why it came into picture, this variadic functions, because for each and every use case where the only the number of arguments for a function is different, right? In that case, we have to add a new definition or new function definition, right? Or we have to overload that function, right? Because features are same, functionality are same, right? The difference is in number of arguments only, correct? So to resolve this or to overcome this problem, the C++ came with a new feature, that is variadic functions, right? So a variadic function is a function that accepts a variable number of arguments, right? So here we have added two definitions, but this requirement can be addressed using one definition only, single definition only, using the variadic functions. That is what we are going to see, right? And that is what it is mentioned here. A variadic functions is a functions that accepts a variable number of arguments, right? In printf, you have seen the printf in C, scanf printf, right? There we can either print pass two argument, three argument, four argument, up to a requirement, right? According to a requirement. We can create a variadic functions using macros defining in cstdarg header file. What are there in this header file? So we are going to use from this header file VA list, VA start, VA arg, VA end. So these are the macros which we are going to use while creating or using the variadic functions, right? So this VA list is a list of arguments which we are going to declare in the function itself, right? And then using the VA start, we will initialize that list. We will initialize that list with the arguments, and then using VAARG, we will retrieve the data or the next argument from that list on the basis of the data type. And then VA end, it is used to clean up the list once we are done with the usage, right? So these four macros we are going to use, and these four macros you have to remember, right, for this variadic function feature, right? So let's understand first with the example how can we write a variadic function. So here what we have to do, right, how can we take a variable number of arguments. So here in definitions, right, so I have added this print number, this is a function name, right, and first argument must be a count variable, right, how many variables are going to be there in the call, right, so that we have to pass, and then we have to comma, and then we have to give this three dots, right, you have to remember three dots, right. It means I don't know as of now how many arguments are there or will be there, right. So this function will work for any number of arguments, right. It can take any number of arguments because we have defined a three dots, right. And then in the function body, what we will do in the function body, I have here said VA list. So we have here declared. So this is the declaration of the variable number of or variadic list basically, right. This is a declaration, correct. So this is a declaration a variable that will hold the arguments, correct. And then using the VA start, we will initialize this list, this ARGS list we will initialize, right. So for that, what it will take, VA start will take two arguments here. First one is the list itself, and the second one will be the count, and count we are getting from the function call, right, as argument here, right. So this count, so now this VA start will basically initialize the argument, this list with the this count number of, or for example count is 5, so with 5 arguments, correct. So this is initialize the VA or list variable to retrieve the argument, correct. Now to fetch, to retrieve those arguments one by one, we are using the loop here, right, till count. So for example count is 5, so 5 times we have to iterate, and using the VAARG we will fetch those data on the basis of the data type. See here, so for example I am passing a list of 5 integers, right. So that is why I am giving here int. So int type next argument it will give this VAARG, correct. So here we will retrieve the next argument in the list on the basis of the data type, correct. And here I am just printing, and it is in loop, so it will go for the next argument one by one, correct. And here in the VA end, I will basically clean up, right. I will clean up the VA list here. So I hope it is clear to you how we are writing the variadic functions here, right. We have to remember 4 things. One is in declaration using the VA list. Then we have to remember the VA start, which is used to initialize, right. And in initialization, what we are going to initialize, this ARGS, whatever the variable we have created using the VA list, this will be the variadic list, right, which will hold the arguments, right. And here we will pass the count, right. Count we are getting as an argument here, right. And then using the VAARG, we are basically retrieving the data one by one on the basis of the data type, correct? And then using the VA end, we are cleaning up the VA list once we are done with the usage. Let me run this one first. So I have compiled this one using G++, and let me run this exe. Yeah. So here see, it is printing 10 and 20. So 10 and 20 is getting printed from print non-variable here from this call here, this one, and then it is printing 11 and 12. 11 and 12 it is printing from this call, right? Print number with 2, correct? So here for this one, let me go to definition here. So count is coming 2, and then here this is getting initialized with 2 arguments, 11 and 12, and here count is 2, so 2 times this will iterate, right? First time it will go and basically fetch the first data 11, and then second time it will fetch the 12, right? Second data. So same function I am calling again with the different number of arguments. Here see, I am passing 3, count is 3, and I am passing 3 arguments here. Same function, right? So no need to add a separate definition for this one. Correct? I am calling the same function here. Definition, this one only, right? This one, same function I am calling again. Correct? So if I am not using this variadic function feature, then I have to overload this function with the 3 arguments basically. But I am not doing that because I am using the variadic function feature here of the C++. I hope this is the advantage of the this variadic function feature. Correct? Now see here, I have added one more variadic function here, where the first argument it is taking string, and then it is taking count, and then after count, it means these 2 arguments will be fixed, and then we can pass this dot dot dot, right? It means at least 2 arguments it will take, and then it will take the variable number of arguments. Here what is the basic condition to call this function? At least 1 argument will be there, then we have the variable number of arguments, and here we have at least 2 arguments while calling, and then variable number of arguments for this call, right? First is string, second one will be treated as count 4, and then 4 here arguments are there, right? So I have added one more call here with these 2 arguments will be fixed. One first would be string and second would be integer, right? And then I can pass the variable number of arguments here, right? So that is I am passing 1, count is 1, and I am passing one argument here. So let me build it again. See, numbers 1 2 3 4 and numbers 11, because here I am passing only 1, count is 1, and I am passing 1 argument here after this, right? So I am not adding any new definitions. If I am not using this variadic function feature, in that case I have to add the new definitions. I have to overload this one. So this is the advantage of this variadic feature, where in traditional way without a variadic feature, variadic function feature, we used to overload the functions, right? So here we are overloading for 1 argument, right? 1 function is there, and 1 function is there with the 2 arguments, but that is not required if we are using the variadic function feature. Correct? So now let's talk about the data types which are supported as an argument here. So in C++, this variadic function feature works only for the POD types, plain old data types, right? Like integer, float, double, pointers, right? Character pointers. In pointers, it is not supported for custom data types, right? But it supports character pointer, integer pointer, like only. If you are like a string, vector, user defined data types, these data types are not supported with the variadic function features, right? So let me show you one example here. So this is a simple example which we have already seen, right? So here this is for integer only, right? Integer we have already seen. For mixed data types, yeah, this one. So here see, as an argument I am passing string also. This is integer, this is string. I am passing count here 6, right? Second variable 6, and then I am passing 6 arguments here, 3 integer and 3 strings, right? Basically these are not the strings, these will be treated as a character pointer, const character pointer, and that is supported. String is not, std string is not supported. right? So likewise, you can pass double or float also, right? So let me build this one. So you can see here numbers 1, 2, 3, 4 from the first, right here, and this and the this mixed one is 1, 1, 2, 2, 3, 3, right? So because here, see, I am printing. First, I am taking number from here, and in the same loop, in the same iteration, I am taking the next. I am expecting a character pointer. See here, character pointer, and that is what I am passing here from here, right? And you can see here, that is why I am basically two arguments I am fetching at a time. So I have this divided by 2, right? So that it will be run only 3 times instead of the 6. So I hope it is clear to you that the variadic functions works only with the plain old data types, right? It does not work with the user defined data types, custom data types, right? Strings, vector, or any class structs, right? Those with those data types, it will not work. It is not supported. So now, if we talk about the limitations of the variadic functions, so the first limitation is type safety, right? Variadic functions do not provide a type safety feature, right? So we like the compiler cannot check if the type of the argument passed matches the expected type or not. This can lead to a runtime error if the type are mismatched. And the second limitation is argument count. So there is no built-in way to determine the number of arguments passed to a variadic functions. The programmer must provide a way to specify the count, often by passing an additional parameter. We have to explicitly tell the compiler using passing this data type, and this is the expected type, right? And if this is not the expected type, then there would be undefined behavior. This is the first limitation, that is what is mentioned here, type safety. Right? Second one is argument count. So this argument count we are explicitly passing, right? If we are passing less or more, then that would also be a basically, if we are passing less number of count here less, and we are passing the more number of variadic arguments here, right? So for example, in this case, see here, so I am passing count as 4, and I am here passing only 2 variables, 2 arguments, right? But this is expecting 4. So in that case, it will lead to undefined behavior, because it will try to fetch the 4 arguments. So I have added the same function, right? Same feature. I am basically iterating in a for loop, 4 count, right? So count I have passed 4, but here I have initialized this arg with 4, right? But I am passing only 2. Right? So it is expecting 2 more arguments, but it is not there. So it may it would be undefined behavior. It may store or initialize with the garbage value. Other case where I am passing the count is 2, but I am passing 3 arguments here. So in this case, what will happen? It will initialize the first 2 arguments. It will initialize this argument list, variadic argument list, with first 2 variables only. So that is also not a correct basically habit, right? So that this is the limitation of the variadic functions, where we the programmer must have to take care of the data types as well as the count, right? So let me run this program here. So number type mismatch, see here, basically the first one here, it is expecting integer in my function definition. See, I'm only expecting integer here, but I have passed this 3.6 and 4 dot, these are the doubles, right? And integer takes 4 byte, double takes 8 byte, right? And that is why you can see here garbage values. This is not handled by the compiler, right? It must be handled by the programmer itself, the data type, right? And the count one, see here, less count, I gave less count, 2 only, so it is working correctly, fine, it is fine, because it is excluding the third one, it is taking only first 2 arguments, right? But if I am passing 4 here, the count is 4, and I am passing only 2 arguments here. See here, 2 garbage values, this is 30, and this is garbage value. So these 2 are the garbage values. It is basically stores data in stack and in the memory, linearly, and it checks the first argument on the basis of data type. For example, we are passing integer, so it will read the 4 byte, right, and then basically advance the pointer to the 4 byte, right, and there we are passing again integer, so again it will read the 4 byte and it will advance the pointer. And for example, then we are passing the double, right, here instead of the integer we pass this varg double data type, then it will read from that point to the 8 byte. Or if we are passing character, then it will read the 1 byte from that point. So like this is the way it basically access the data or retrieve the data, right. So here that is why it is there must be a exact type, exact data type, then only we will get the correct data, otherwise we will get the undefined behavior, we can get the garbage value. In the next or upcoming session we will discuss the variadic template, right, and these sessions are interrelated. So I basically request you to watch the complete video to get the complete knowledge. Like template sessions I have already done, so if you are if you want to watch that template related video where I have discussed in detail each and every aspects of the template, right, uh, if you are done with these variadic functions, then upcoming session would be very easy for you, where we will discuss the variadic templates, right. If you know the templates and variadic functions, then it would be easy, because the variadic templates would be the solution for these limitations of the variadic functions, right. So here the programmer only have to take care of the data types and the number of arguments, the count variable, right. So that these problems will be resolved with the variadic template feature, right. So that we are going to discuss in the upcoming sessions, and then we will discuss the fold expressions of the C++ 17 feature. So these are the basically upcoming sessions. So yeah, thank you for watching the complete video. See you next time. Till then, keep learning and keep exploring.